about overfitting, underfitting, the concept of generalization, and cross-validation. First, we studied the overfitting, which results due to the fact that your model not only learns the general concepts model learns not only the general concepts but the noise in your data. Therefore, it leads to poor performance on new data. Underfitting was a concept when the model neither learns the general concept and also performs bad on your new data. So the idea is to just leave that model and select a new model. And underfitting is very easy to detect because your model is simply not training. You don't have a good accuracy. Your accuracy of 0.02% is not good. So it is very visible. So you need to switch to another model. Then comes your different approaches. We studied the loss functions and learning rate concept. Low or very high learning rate was not suitable, and a good fit model will have an optimal learning rate. So some of the topics we have covered so far. Then the data partitioning and the concept of training loss, the concept of validation loss, and the testing loss. So the training loss is estimated per batch, and then it is averaged out at the end, and validation loss is estimated after each epoch. And when your training is completed, your testing loss is estimated. So we first studied the training and evaluating the model using training and test data splits and random splitting, and what is the disadvantage of random splitting. And then we have the cross-validation concept and studied the average performance of cross-validation. Okay. Then there are different approaches to variations of your cross-validation concept. We also studied that. And one example I think we are left with, how we can address the overfitting concept, right? I mentioned that one example I will give at the end. Yes. This example, I said that how we can address the problem of overfitting. One example of this is using pruning decision trees and pruning in a non-parametric model. So a decision tree is basically a non-parametric model, and I wanted to show you an example that yes, overfitting can be addressed using different techniques, and I will give you one example. So we start with different nodes. In the decision tree, we have different nodes. For example, income of a person. We are trying to estimate either the loan should be given to the person or not. Okay, if the income of a person is greater than or equal to 30K, then we split it. If it is greater than or equal to, yes, we move here. And did the person take loan from another bank? If there is no and there is yes, so they take the loan from same bank. If it is a yes, then the loan is given to that person. If it from the same bank he didn't take the loan, then we check the required documents of that person. Are they given? Yes, then the loan is given to that person. No, in that case we collect the documents and then give the loan. So if the person, and the other split was your decision tree. If the income is less than 30K, we check the criminal record of the person. They're already there. If there is some criminal record, then no loan. But if there is no criminal record, we check the required documents, and if they are there, we give the loan. Otherwise, if the required documents are not there, we don't give the loan. So no means loan is not given, and yes mean the loan is approved. So how we can prune this tree? Prune means we can remove some of the nodes. Pruning is removing some nodes. Why? Because the complexity is too high of this decision tree. So first we have the income, and then we split it into if it is greater than 30K, okay, we already the person took loan from same bank, then we choose yes. If that person did this, so loan is approved, yes. Otherwise, we check the required documents, and if they are not there, here we have no loan. So we have no loan. Required documents should be there, and if the documents are there, the loan is approved, yes. So pruning is that the information about the criminal record has no meaning if the person does not have a monthly income of greater than 30K. So we just remove this information. This node, criminal record checking, is removed, and the decision tree, you can see how many decisions are reduced. Next two-step decisions are reduced, and we don't have to check other details of the person. So if the income is less than 30K, we simply don't give the loan. So this information, this part of the tree is, this node is pruned, and therefore all the nodes leading to that are removed. So one of the example of addressing overfitting is pruning in decision tree. And what is pruning? We remove some of the nodes from the decision tree because they are adding to too much complexity in our network, in our decision tree, and do not add too much value in terms of information. So this is one of the ways in which we can address the overfitting issue. So I hope that you have understood the basic concepts of overfitting and data partitioning concept, and why we need to have a generalized model instead of a very well-trained model on the training data, because only then our unknown samples can be predicted accurately using our machine learning algorithm. If you have any questions, you can either drop a comment under the video, or you could ask me in our lectures.